2, 3, 4, 5, 6, 7, 8. 8. Yes, everybody's here. I understand Gina is not able to attend the meeting. So everybody's here right now. Perhaps the others can identify themselves.
Juan Mariscal. Juan Mariscal.
Joe Keogh's there. Mike Crawford is there. Chris Stanley is there. Michaela Ricky, am I pronouncing that right?
It's Riki.
Riki, okay. John is there. Bill is there. Goslin. Bob Martin is there. Tom Craig. George Champlin. Mark. Doreen Schiff. Genevieve Geiser. Is that correct?
Yes.
Okay. Myself, Pam, and Colleen Deshanes.
It's
Did I
actually.
pronounce that right?
It's Angelina Deshanes. That's how.
Oh, okay. Colleen is the mother.
That's the name of the thing.
Gotcha. All right. The first item is the presentation of awards for the Rhode Island Science Fair winners. And I understand that arrangements have been made for each of the winners to give us via Zoom, give us a brief explanation of what their winning project was. Who'd like to go first?
I'll go first.
Sure.
Okay. So my name is Angelina Deshanes, and I did Weeds Be Gone, but at what cost? It's the effect of weed killers on the water quality in the Kickamuit River. And this is an actual continuation of my last year's project, which was too much, which was the effect of fertilizer on the Kickamuit River water quality. And both of those projects were based off of when I went to Florida 3 years ago, and there was a lot of dead fish in the water, and that was due to algal blooms, which is because of excessive nutrients in the water, and that's because of weed killers or fertilizers. So the water quality I tested for was oxygen, pH, ammonia, nitrate, and phosphate. And the weed killers I used were a homemade weed killer, which was consisted of vinegar, dish soap, and Epsom salt. And then I also used Roundup and Spectricide, and also controlled. So my hypothesis was that I thought the Roundup weed killer would negatively affect the water quality the most because it contains a chemical called glyphosate, and that is known to cause cancers and be hurtful to the environment. And after testing, I concluded that it wasn't just only the Roundup, it was pretty much all the weed killers negatively affected the water quality. And since the results were so close, I couldn't determine a specific result. And that's it. Any questions?
Even the homemade one, which presumably didn't contain any weird chemical names, that was just as bad.
Yes, it was.
Colleen, you were a student?
Yes.
Say it's Angelina.
It's Angelina, actually.
Angelina.
You tell her you're an 8th grade student at
Oh, I'm an 8th grade student at St. Luke's.
Okay.
Very good.
And Angelina was our first place winner last year as well, which is the project that she mentioned that led her into this one. So we want to give her a big congratulations, especially for doing a follow-up and doing it extremely well.
Thank you.
Who is next
But I just want to mention that this year they weren't able to do their presentations for the usual science fair, and they put a lot of work into these projects. So Sue actually did continue with her judging and recruited a few people here and Chris to help us out. And we want to thank Sue for doing the work, but also giving everyone the opportunity to do their presentations. And we do have an award for Angelina, and it'll be a $100 gift certificate.
Thank you.
If I could just chime in, I'm the teacher at St. Luke's School with the Science, and I just really want to thank Sue and the staff at BCWA for giving us this opportunity, because we were all set and excited to go to the State Science Fair, and you really allowed us to have an authentic audience to the excellent work that these students did, and we're so very appreciative of this opportunity. So thank you very much for it.
You're quite welcome.
I think we have,
Our second place in the junior division is Genevieve and Michaela. They want to go next?
Sure. So we are both also in the 8th grade at St. Luke's School. And our project was called Diffusion of Pollution, the effective density on the diffusion rate of liquid pollutants into water. And so we were comparing how quickly two liquid pollutants, a solution made from Jiffy Melt ice melt, and then a solution made from Schultz's plant fertilizer. We were comparing the rates that they diffused into distilled water. So diffusion is the movement of particles in a solution from a highly concentrated area to a less concentrated one. And we measured this by layering the two solutions, well, by layering one of the solutions with distilled water in a cuvette and then letting them diffuse into each other. And as they diffused, we shone a laser beam through the spot where the two touched, and it distorted the beam into a curve that lessened as they became more and more diffused. And we were able to use the curve to calculate the rate of diffusion.
We found that the ice melt diffused faster into the distilled water than the fertilizer. Both of them are pollutants and they affect water quality in different ways. And yeah, so there are many variables in determining how and where pollutants spread into water, and we tested one of those, which is diffusion.
Very interesting. Any questions anybody has? Was there any other, well, I guess you restricted your investigation to only 2 items. Was there anything else that you were aware of that would that might be more appropriate to use on these circumstances rather than the 2, either of the 2 that you did investigate?
So we thought of fertilizer from the beginning because we knew that it added like nitrates to the water and could cause like an increased growth in algae and stuff. But then we weren't sure about ice melt until we found that it needed to like be able to diffuse into the water. And so that limited it quite a bit.
Yeah, because at first we wanted to do ammonium nitrate, and we found, I think it was in ice packs that they had it, but it was coated in calcium, so it didn't actually dissolve into the water. So we couldn't test it.
I understand.
What grade are you students in?
They're at the same school.
Yeah, but what's the grade?
yes.
They're at St. Luke's, but what year are they in?
We're also in 8th grade.
8th grade.
8th grade. Oh my gosh, it's way over my head.
And so the second place winners receive $50. And the check will be sent to them, and our heartiest congratulations.
Definitely.
Job well done.
Job well done, yes.
Yes. Thank you very much for participating.
Thank
Yes, we
you.
go to the senior division.
Thank you.
Aaliyah Carrion and Drew Tyska. Did I pronounce that correctly?
Tiska, but close enough.
Tyska. Close. Okay. Why don't you tell us about your project? These are ladies from Mount Hope.
Aaliyah, do you want to start?
Sure.
Is she speaking?
We have like
Your voice is not coming through.
think she froze up, Alan.
Voice is not coming through. Try it again.
Maya, you may have to try a different location. Your signal is breaking up. I don't know if you can
I
hear
think
me.
she's gonna try to leave and come back. Oh, she's gonna join on her phone to see if it's better.
Okay.
Now, some of these pictures have a little red symbol in the left-hand bottom corner. What is that?
Say it again, John.
Some of these pictures have a little red symbol in the bottom corner. What is that?
They're muted.
That's when you
Oh, they're
mute it.
muted.
If you mute
Okay.
yourself, you can use your space bar to come in off of mute.
I see it, yeah.
Okay. Somebody
Coming
ready
in
from the
on the
team?
phone.
I think she just disconnected. I think she's gonna try to join back in on her phone.
Okay. While we're waiting for her, Aaliyah, why don't you tell us the exact name of the project? Most of us have trouble even reading all the syllables.
So the name of our project is Evaluating the Effect of Denitrifying Bacteria on Algal Growth.
Wait,
No.
I think I'm back. Okay.
Yep, it's
I
working
had
now.
to check my phone. Okay. Can everyone hear me now?
Yes.
We can.
Yep.
All right. So I could hear you guys, but I guess you guys couldn't hear me. I don't know why. But so I have my presentation on my computer here. I don't know how to switch the camera. It's like a PDF here. So I guess I'll just give you guys an overview with our abstract. So our project, basically, we wanted to relate it to the environment. We're both really big into environmental science, and we are surrounded by water here in Rhode Island. So we wanted to do something that related to the water, because that's something that's pretty close to home for many of us. So when we thought of a problem within our water, it's toxic algal blooms, which the first presentation had hit on, I heard. But so basically we said algal growth is largely influenced by nitrate levels in a body of water, which causes an abundance of negative effects on an ecosystem, as many of you guys know. So our experiment was conducted to explore the effects and capabilities of denitrifying bacteria to reduce algal growth in hopes to avoid ecosystem devastation, eutrophication, and toxic algal blooms. And eutrophication, if you don't know, it's basically when the abundance of like algae and other not so good plants in an ecosystem take up all the oxygen, and then the organisms within it actually die because they have no oxygen. So it was hypothesized that if Pseudomonas fluorescens is the most effective denitrifier, which is a type of denitrifying bacteria, then algal growth would be slowed due to a lack of nitrates present in the given water samples. So to test the hypothesis, we used a spectrophotometer. So it provides an indication of algal growth based on absorbance units. So basically what it does is it sends a beam of light through a sample of like water we used. And that's the method we used. So some of our samples had previously contained denitrifying bacteria, and they were compared to those that did not have that bacteria, and they were both inoculated with Volvox algae. So the experimental results indicate the superiority of Pseudomonas fluorescens as a potential denitrifier in algae-prone water bodies, and subsequently the effect of Pseudomonas fluorescens on marine life was then tested in the second part of our experiment, because we did 3 different parts, because we did 1 for our school science fair and then 2 for the state science fair. So we used Daphnia, which are like water fleas, to resemble marine organisms. And it was hypothesized that Daphnia's heart rate would decrease among the Pseudomonas fluorescens due to an inclined rate of stress. So when their heart rates go down, that means they're stressed out. And the experimental results indicated that Pseudomonas fluorescens to be used in real life can be used in real life freshwater ecosystems, but it must be introduced in an indirect manner in order to not present a threat to marine life, whether that be filtration or some sort of way, which we were thinking of continuing next year. Drew's going off to college, but I was thinking of doing
a continuation of it for next year's science fair. So Drew can talk about kind of like the methods we went through if you want, Drew.
Sure. So for the first part of our methods, I'm just going to explain what we did for our school science fair as our original project. So first, we made 3 varying media. One of them was a mix of nitrate broth combined with Pseudomonas fluorescens, which are a denitrifying bacteria. The second is nitrate broth combined with E. coli, which is another bacteria. And the third was just plain nitrate broth. And after we let those 3 media sit for, I think it was 2 weeks, we filtered out the E. coli and the Pseudomonas fluorescens from the solutions. And the reason that we filtered out the bacteria is so that we could have, there wouldn't be any competition within the solutions, and the bacteria had affected the nitrates, denitrifying it before we could combine it with algae. So our next step was to combine it with Volvox algae, and then following that was a 10-day testing period where we'd observe the absorbance of each solution over time with a spectrophotometer, and that way we could track the algal growth over a 10-day period and compare each different bacteria and how they affected algal growth.
So then for the state science fair, we had to kind of add an additional step to our project and put a sort of kick on it. So we, instead of filtering out the Pseudomonas and the E. coli, even though we didn't use E. coli for the second part, so I don't know why I said that, but we didn't filter it out to see how Pseudomonas would interact with Volvox and see if the competition had a negative or positive impact on the algal growth. So we used 4 germ tubes, 2 with Pseudomonas and 2 without, just so we could have obviously more data so we could create averages and whatnot. So we diluted all of the germ tubes with 7.5 milliliters of distilled water and nitrate broth, so it was a 50-50 dilution. And some test tubes had Pseudomonas, some did not. And then the ones with Pseudomonas were incubated so that the bacteria had time to multiply. And then we added in a 50-50 ratio of box algae. And then we did another 5-day evaluation of absorbance under a spectrophotometer and recorded the data again. And then for another part, as I touched on in the abstract, we added Daphnia into samples with Pseudomonas to see how the Daphnia would impact, and basically how you calculate stress in Daphnia as you detect their heartbeat. So what you have to do is you extract the Daphnia from the water, put it under a microscope on a depression slide, and for 15 seconds, you take, usually it's ideally you take a video so you can slow it down because their heartbeats are really fast sometimes. You calculate their heartbeats for 15 seconds, multiply by 4 to get the beats per minute. And we repeated it with 4 different Daphnia so we could take averages. And we compared the Daphnia with Pseudomonas and without. And overall, you see that we didn't use E. coli for the second part of our experiment because we found in the first part that Pseudomonas was the superior denitrifier. So there was no need to compare to E. coli anymore because we knew it was obviously more beneficial. And Drew, if you want to get into maybe our results, which I kind of touched on.
Yeah, Aaliyah briefly touched upon them, so I'll just briefly go over the results of each part. So for part 1, the results that we came to was the media with the Pseudomonas fluorescens had stronger denitrifying capabilities than both the E. coli and the nitrate solutions. And then for part 2, we found that on average, Pseudomonas fluorescens had a much slowed algal growth significantly, having only a 0.244 growth rate in absorbance units per day, whereas algae without Pseudomonas fluorescens had a much faster growth rate of 0.317 absorbance units per day. And then for the third part, we found the results that Daphnia that came in contact with Pseudomonas fluorescens started at a low heart rate of 81 beats per minute and then inclined to a rate of 185 beats per minute. And then Daphnia not in contact with Pseudomonas fluorescens started at a heart rate of 207 beats per minute and then declined to 159 beats per minute by the end of our testing period.
So an average Daphnia heart rate is that's healthy for the Daphnia is anywhere from 160 to 180 beats per minute. So we found that the Pseudomonas at first had a really negative impact, but then the Daphne kind of got adjusted to it over time. So which suggests to us, if we were continuing our experiment next year, to come up with a system where we could utilize Pseudomonas to reduce algal growth without having it directly impact the marine organisms. We've talked about a filter, a biofilm, and it's all just ideas we're going to play with next year. And it's pretty much what we did overall.
Fascinating. Any questions?
Girls, if you have any extra time on your hands, why don't you see if you can find a vaccine for the coronavirus?
All right.
Thank you very much, ladies.
Thank you.
You're going off to college, Drew?
Yes, I'm going to the University of Richmond in Virginia in the fall.
Have
Very
you
good.
picked have you picked a subject to specialize in that has anything to do with this project?
Not really. I'm actually, as of now, I'm going into business, but I'm not sure if that'll change in the future because I'm also interested in environmental science.
Very good. Best of luck to you. And as
Thank you.
I think you've already been made aware, each of you gets a $100 check as the first prize in the senior division. And we thank you, ladies, for all your work and your interest.
Thank
Appreciate
you.
that very
You're
much.
welcome.
Thank you.
Best of luck, girls.
Thank you.
Thanks.
And finally, I guess we have the second place winner from the senior division, Callie Bouchard, Mount Hope. Is Callie here?
I see your name.
I see her. I have her.
Unfortunately, Kelly, we can't hear you.
Can't hear her.
Can you try a phone?
Looks like a weak signal from whatever device she's using.
Yeah.
I just messaged her to tell her to try it on her.
Very good.
Oh, wait. This is a test. Can you hear me?
I lost George, too.
Yeah, I lost him.
I think Callie is frozen at this point.
Here we go. Yep.
There's George.
Yep.
Well, we see her, but she's frozen. Is she going to try on the phone?
I messaged her. She hasn't replied yet, so I think she's probably trying to do that now.
Okay. Who was in phone call? Oh, you sent a message. Who was it that sent the message?
Aaliyah.
Okay.
Hmm.
I don't know. What do you say we do? We give her another couple of minutes, then we got to move on. We have a busy meeting.
Yes, we want to finish this meeting and then maybe by the end she'll have some connection.
She's trying to connect right now.
Oh, okay.
Okay. Can everyone see and hear me now?
All
Yes, we
right.
can.
I'm
Yes.
sorry. I'm sorry. It took so long for everything to load. I'm sorry. So I'm Kaylee. I'm a junior at Mount Hope High School. So my science fair project, it's titled Glow Green, evaluating a bacterial GFP biosensor for water contaminants. So basically, I had started to think about water and how like it was affected by like different chemicals and like how it can be harmful because, again, we do have a lot of water here. And so I hypothesized that if pea green cells are introduced to a chemical such as like bleach, then the cells will continue to glow less over time because they'll die after coming into contact with the contaminant. So therefore, I thought that pea green mixed with E. coli bacteria would be a great biosensor for water contaminants. So basically, I started with, I had to create my E. coli bacteria on a spread plate, and then I had to genetically modify it to have the pea green gene, so it would glow under the blue fluorescent ultraviolet light. And so I had taken my cells that were glowing and I made them into a solution. So then I could pour it into a micro well plate. And then I filled up 16 wells in total. And the first row of 4, I had a control. And then I had a control, and then I had 10 microliters of water, 100 microliters of water, and 1,000 microliters of water. And then in the next column, I had 10 microliters of bleach, and then 100 microliters of bleach in the next column, and then 1,000 microliters of bleach in the next. So basically, I wanted to see how just plain distilled water would affect the chemicals, because the data that I was getting was based off my eyesight. And then I wanted to compare it to the bleach itself. So basically, over an hour, every 5 minutes after I put the bleach into the chemicals, I would take a picture to see the decrease in glow over time. And then I tested bleach because I knew it was a killer, so that's why I wanted to start with. I knew it was a very strong chemical. Then I researched and I found that zinc chloride and copper sulfate were both common chemicals that like were in water from runoff. So I tested both of those and I had to make those into a solution. So then I would test them all and then see their decrease in glow over time. I used the same process as I did with the bleach, with the zinc chloride and copper sulfate. And I had to create a chart and rate their glow based off my eyesight because I didn't have anything to measure the glow, like a tool or anything. So then I made a chart and I made a system. And so after that, I plated each of the cells after I went through the hour trial to see, because I knew that a scale based off my eyesight wasn't as accurate so as it like could be if I had a tool. So I plated each of the cells and to see how much they grew, to see how many cells were killed, and then to see also how much they glow. So basically at the end of everything, the bleach killed the most of the cells, and then copper sulfate was next. It killed a lot, but just not as much as bleach. And then it was zinc chloride last, and zinc chloride didn't do as well performing, but it still killed some cells. It wasn't as visible. But basically, so overall, depending on the chemical, I saw that this type of biosensor, so a bacterial GFP biosensor, could detect certain chemicals, just not all of them. In the future, I was hoping maybe next year, maybe to dilute the chemicals, since they will be present in water when they would be detected. But overall, I believe that's it.
Okay. Thank you. Any questions?
Excellent.
Very nice.
Thank you.
Thank you.
We'll see you next year.
I hope so.
Once
That's
again,
right.
thank you for participating and focusing on water.
Of course.
And for your effort, you received the second place prize of $50. That check will be sent to you.
Thank you.
We thank you very much for your interest.
Take care, girls.
Thank you.
Thank you. Good luck.
You're certainly welcome to stay for the rest of the meeting, although you may be dumbfounded by everything that we talk about, just as much as we were amazed at the details that you ladies talked about. But you're welcome to stay.
Thank you.
Thank you.
Thank you.
Have a good night.
Thank you, everyone.
Good show, girl.
Thank you very much.
The
Stay
next
safe.
item is the annual report and the FY21 audit. I guess that's Mark.
There's the annual report. It's in progress. We'll have it in July. Mark can talk about the audit.
Right. You want me to start, Pam, or you want to start?
Oh, I just did.
Whose
I
dog?
just passed it to you.
Whose
Okay.
dog is it?
Actually, today we're just finishing up, believe it or not, week number 5 of the audit, which has been accomplished remotely, which has been a trying task, but we're getting through it. And the auditors actually were in the office yesterday, 4 of them, for the only site visit of the audit. And we finished up yesterday. I thought, and then there was a few things to wrap up today. So I'm hoping they're going to take all this information back. I'm sure they'll have more questions, but they're in the process of preparing a financial draft. And I should have that hopefully in about a week. And then after the draft, I review that, get back to them that I'm in agreement with their findings. And then they produce a final copy. At that point, I will work on the MD&A, which is basically management's discussion and analysis of the year and any findings they had. Once I finish that, I send it back to them to approve the MD&A. They incorporate my MD&A in the financial statements, and then we're good to go. We will get it. That would be the audited financial statements, and that would be incorporated into part of the annual report, basically the second half of the annual report. And that's kind of where that stands right now. So it's been the new norm, working through Zoom and things that they could look at in the office now have to be scanned back and forth with comments. So it was an interesting process so far. So
But it's happening.
It's happening. So we need to get a audited financial to the bond trustees by June 30th. And I applied to them for an extension, if possible. I mean, the auditors can only work as fast as they can work. They're basically working from home too. So we're at their mercy that we can get this all done by the June 30th. U.S. Bank, the trustees said the documents, the governing body of the documents does not allow an extension, which I find difficult during these times. So I'm going to keep tabs that way. I got to push them to make sure we get to that point. I'll see. I might, all I asked for was, 15 to 30 days if necessary. So everything else seems to get an extension. I don't see why that would not. But that's my portion of, actually it's the FY20 audit on the, there's a misprint on the agenda. that would be next year's audit. And I can
Right.
talk about that a little bit if you want, but I'm not going to. Okay, Pam,
Okay.
you can give the update on the annual report, right?
I gave a quick one before
You
you
already did.
started. I just said it's in progress. We've gotten all the information together. It's in the hands of the RDW group, who is organizing it and going to be printing it. They'll be, they won't be able to print it until they get Mark's audited numbers, though. So once those are all ready, we should have it by, hopefully by the July meeting.
Okay. That's not any other questions anyone has. Moving right along, we're on item number 4, the nomination and election of officers for the coming year.
Mr. Chairman, I'd like to move the nomination of Alan Klepper for chairman of the Bristol County Water Authority.
Klepper has been nominated. I remind everybody, if you've got your copy, requires a minimum of 6 votes, and at least, I believe, from at least one from every town. Every town has to be included. We have 8 members here, although where'd Tom go? Oh, he's back now. Okay, we got 8 people here. Are there any other nominations? All those in favor of Alan Klepper to continue as the chair, I will call off the names here. Bob,
Bob says yes.
Bill,
Yes.
John,
Aye.
Juan. Juan, you voting?
Yes.
Muted.
Yes, okay.
He was on mute.
Chris,
Yes.
here we go. George
Aye.
and Tom,
Yes.
and I vote as well. Thank you. Appreciate the allowing me to stay in office for a while longer. I hope I live long enough.
And congratulations, Alec.
Can I take the
Mr.
bumper
Chairman.
sticker off my car now?
Mr. Chairman, I'd like to move the nomination of Bill Gosselin for vice chairman.
Are there any other nominations? Hearing none, we'll go through the perfunctory check on everybody. We'll start with John,
Aye.
Juan,
Yes.
Chris,
Yep.
George,
Yes. Aye.
Tom,
Yes.
Bob.
Yes.
I vote yes. And finally, Bill.
Yes.
And again, by acclamation. Congratulations.
Thank you very much,
Treasurer
gentlemen.
Secretary, that requires 5 votes instead of 6. Although I wonder why, because it's a double office. Voting nominations for secretary treasurer, or treasurer secretary, excuse me.
Mr. Chairman,
Yes.
I'd like to move the nomination of George Champlin for secretary treasurer.
Are there any other nominations? Again, hearing none, let's go through the vote to make this official. We'll start out with Bill,
Yes.
George, John,
Aye.
Juan,
Yes.
Chris,
Aye.
Bob,
Yes.
Tom.
Yes.
I vote yes. And George, finally,
Aye.
and it is unanimous.
Congratulations, George.
Oh, thank you.
Congratulations, Bill and George.
The next item is designation of the committees and appointments and members. I think my current intent is to leave everybody exactly where they are at this moment. You've all had an index or a paper that describes the functions of each of the committees, what's expected of them, and the current makeup. Just to repeat it for the record, for personnel will be John as chairman with Juan and myself. The finance claims committee will be George as chairman with Gina and Chris. And the policies and procedures will be Bill as chairman with Bob Martin and Tom Craig. And the detail, I'll resend those details. And if anyone in the committees feels that there are other functions that they would like to take on, let me know, and we'll see about adding those into the responsibilities. Congratulations to all of you. I hope you've been working well together. I hope that part continues. I think that we have an adjournment to the regular meeting, which would have started at 6:30. Technically, I guess it's a separate meeting, or can we continue with this one, Pam?
No, it is a separate meeting because you'll be entering in a waiting room, and I'll have to bring everyone into the meeting. And then when we have an executive session, I'll have to put anyone that's not involved in the executive session into the waiting room.
Gotcha. Okay, so I guess we will entertain a motion to dissolve this meeting.
So moved.
Second.
All those in favor say aye.
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 Could you say it again, please?
Aye.
Everyone has said aye. It's unanimous to dissolve the meeting at 6:42. We'll see you all in a few moments.
Thank you.